Hi, in this video I'm going to show you the key features of a function, which are the domain, the intercepts, parity, sign, asymptotes. The other two key features, monotony and points of extreme and convexity and points of inflection, are subject to the calculus and vector scores. These key features are studied in the advanced functions course, though you might not necessarily be aware of that because the approach in class is different. They study every single function independently without pointing out to these key features necessarily. Each of these key features can be an independent question that you might have, or all of them combined. So for example, you might have a question that will state find the domain of the function, or find the intercepts of the function, or just find the x-intercepts of the function, or study the sign. So in this video I'm going to just present roughly what each of these key features represent. If you think that these are too many key features, just think of a story. Let's say, for example, I'm hiring you to build a highway, and you might have some questions. The questions that you might have might include, in the first place, where should I start? Where do I end it? So this would be the domain. So where do I start? Where do I end? So that would be the domain. And as you remember, the domain is the set of all values that x can take. Okay. And after that, you might ask, so do you want some cities, towns, villages that you want to this highway to go through? So those would be eventually, because you're going to have a set of axes of coordinates, you might need some helping points. As you remember, all graphs are drawn by plotting points. Obviously we can't plot all of the points, so for that we're going to take some points that will help us draw our graph. So the easiest points are going to be the intercepts, x-intercepts. So here there could be a lot of them. So x-intercepts, so intercepts in the first place, which can be x-intercepts or y-intercept. We'll see what that is. The next thing, it might be helpful to know that our function is symmetrical. So if you know that the function looks exactly the same on one side of the y line and on the other side, so let's say this way, all you have to do is to draw the graph on one side only and then just reflect it into the y line. So that would be what I call the parity. The next function would, the next key feature would be the sign. It's going to be helpful to know if our function is positive, where is it positive, where is it negative, because let's say, for example, I would know that my function passes through these 2 points, and well, ignore that. So, and through that point. Now, how many ways can I draw a function, a graph? I can draw one that goes like that, or one that goes exactly the opposite way, or I can draw one that looks like this. Okay, so it's helpful to know its sign. Now this sign is going to be part of the inequalities. You're going to learn how to solve inequalities, and then it's going to be the asymptotes. These asymptotes will show us what happens where we cannot see the graph. What happens when x goes to plus infinity? So you don't see it anymore. What happens when x goes to negative infinity? You might not see it anymore, or positive infinity, etc. So these are the ones. So let's get into more details with each one of them. So the first one is the domain. Domain usually is the set of all real numbers. So usually you would have x belongs to the set of real numbers. But sometimes there are some restrictions that can apply. Restrictions that are specific to some functions, or restrictions that are due to the context of the problem. So let me tell you what I mean. For example, if you have a square root of a number, you know for sure that for now, unless you've learned complex numbers, you don't know how to calculate the square root, but only of a positive number, which is 3, for example. Root of 9 is 3. So you wouldn't know root of negative 9, because what number times itself is negative 9. So that's why a restriction that would apply to the radical function, to the square root function, is that all the quantity under the radical sign should be positive. That would be a type of restriction. So in this case, the domain would be x belongs to R, positive, all the positive real numbers. If for some reason I don't want 0 to be in here, okay, then I can just take it out. Some other restrictions due to the context of the function might be, let's say, you have a function y equals 2x plus 1, where x represents the age of someone. Well, obviously, the age of a person can't be lower than 0, so x obviously should be bigger than 0, or equal to 0 the moment of when the person is born. And up to, well, if you're very optimistic, you can think of up to 200 years old, but it can't go all to infinity, well, as far as we know. So this is about the domain. Again, it can be, usually it is the set of real numbers, and you have to take out the values that don't apply to that specific case. The second one would be, the second key feature is the intercepts. The intercepts can be, as I said, x-intercepts and y-intercepts. So let's talk about them. The x-intercepts are the points where the graph touches or intersects the x-line. So we might have some. Okay, so assume we have 3 of them. Let's see how we can find them. So what do you notice? What do you know about all points that lie on the x-line? So for example, the coordinates of this point might be, roughly an estimation, -2, 0. Okay, the coordinates of this point might be roughly -1, 0. The coordinates of this point, 1, 0. This one, the coordinates are 2, 0. What do you notice? Well, you might have noticed that the second coordinate, which is y, is always 0. So that's the way we find all the time the x-intercepts. We just write y equals 0. Y or f of x equals 0. By doing that, we have an equation. So here we're going to study how to solve equations. Getting back to, or moving on to the y-intercept, let's see what happens on the y-line. Now I said y-intercept. Is this correct? Can I have more than y1 intercept? Well, if you remember the definition of a function, it says that each x from the domain should have one and only one image. So to this x, which is 0, you can have only one image, be it 1, be it 2, be it 3, be it 0.27 minus 1.3, doesn't matter. So you can have only one y-intercept. But let's see what happens to the y-intercept. So roughly the estimation would be 1, 0, 0, 1, 0, 2, 0, 3, 0, negative 1. So what do you notice? In this case, x, the first coordinate is always 0. So to find the y-intercept, you make x equals 0, and you substitute it in a function, which usually is f of x. So instead of x, I'm going to write 0. So you calculate f of 0, and you get the intercept, the y-intercept. So to recap, to calculate the x-intercept, you have to make y equals 0. To calculate the y-intercept, you make x equals 0. The next key feature is the parity. Parity means if a function is even or odd. An even function is that function for which f of x equals, or I should say f of negative x equals f of x. This is an even function. That's the definition. And that's the way you should know it. An odd function would be f of negative x equals minus f of x. Odd. A function can be even, can be odd, or can be neither. So an even function, let's say, I'm going to just give you an example, f of x equals 2x to the 2 minus 3x plus 1. If I want to calculate if a function is even or odd, I would start all the time with calculating f of negative x. If the answer is the same as the original function, then the function is even. If I can factor out the minus, and what's left from the factoring is the same as the original function, then the function is odd. If I can't do any one of these, so I can't obtain f of x by any method, then the function is neither even nor odd. So in this case, I would calculate f of negative x equals 2 times minus x squared minus 3 times x, negative x plus 1. If I were to compute, that would be 2 times negative x squared is x squared, you know, negative, any number to an even power is positive, so 2x squared, minus 3 times minus x, that makes it plus 3x, plus 1. Is this the original function? Is it 2x squared minus 3x plus 1? Not really. So it's not even. Is it odd? If I factor out the negative sign, negative, that means all of these signs will change. So it's going to be negative 2x squared minus 3x minus 1. Can I say that this function in the brackets, is it f of x? No, it's not. So in this case, our function is neither. The next feature is the sign. So the sign of a function will ask us when is the function positive, when is the function negative, and obviously when is it 0. And for this you're going to study inequalities. This is a lesson by itself. And the asymptotes refer to those areas where we can't see what happens. So the asymptotes can be horizontal or oblique and vertical. This is another lesson as well. So see you at the next lesson. Bye.